Thank you, Ariadne, and pleasure to be here this afternoon. I'm Steve Conant. I'm the VP for Commercial at Veer. My colleague, our Chief Technology, Tim Heidel, worked on the Grid of the Future project here at MIT, and he is the sort of inspiration behind the organization, behind the company. So we all know what the difficulty is. We need to wean ourselves off of fossil fuels. And in order to do that, we need to use more renewables. The difficulty is that renewables aren't where we live. They're located away from us, whether it's a solar farm, a wind farm, offshore wind. So that means that you need transmission to get that energy to markets, to where the load is located. So enter the next problem. Nobody wants these in their backyard. At the scale that you need to move large amounts of renewables to the places where people live, it's a problem. Siting has been the real challenge for a number of projects not getting built. We actually need to build out our transmission system to meet our renewable challenges by 2050. It's an investment of anywhere between $500 billion and $1.4 trillion. So how's that going to happen? Veer is working on a technology. Now, I know I'm here with a bunch of physicists, so you know what the name of the company is. It's Ohm's law. Voltage equals ampacity times resistance. We eliminate the resistance, so you can get a lot of capacity in a very small space. So instead of having power lines that look like this, you can have a power line that looks like this. Now, sure, it's above ground, but it's a lot less intrusive to the landscape, or if you live in one of these houses. So how do we do this? Well, there are materials, superconductors. They were discovered in 1901 by Onus, and he found it with mercury. Found that if certain materials, if heated to a critical low temperature, in this case 4 Kelvin, that it exhibited no resistance. Well, that was fine in 1901. That was nice. What can you do with it? Well, fast forward to 1986, and it was found that there were other materials that at the temperature of liquid nitrogen, 77 Kelvin, hence high temperature. Now, high temperature is only if you're talking Kelvin. It's still 200 degrees below 0 centigrade. But those materials, so what you need to do is, in order to get that superconducting material, you need to cool it. So in 2007, there were companies that worked on actually cooling that. But what they used was a closed-loop system. So they needed to circulate the nitrogen to keep those tapes inside it cold, so they had no resistance. So anytime you have it's basically a small substation, a lot of moving parts, a lot of mechanical systems, a lot of things essentially that can go wrong. So the industry, its application for transmission is pretty much stuck in 2007. What Veer's doing is we're not doing anything with the superconductivity of the tapes. We're actually innovating on the cooling system. So instead of using simple cooling, we actually use a very simple, I'm not a physicist, but I know what the latent heat of vaporization is. It has 20 times the cooling power. We evaporate a portion of that liquid nitrogen. And in doing that, that change in state from liquid to a gas actually has 20 times the cooling power as the simple refrigeration systems used in previous iterations of superconductivity in the electric markets. So that does a couple things. It means our components are much lighter. For this first time, you're going to be able to go overhead and move power overhead in conductor lines, and that's going to make us competitive with traditional conductors. And we can move 5 times the amount of capacity that you can with a traditional line. So if you have a 115 kV line that can move about 200 megawatts of power, using a Veer conductor, you can move 1,000 megawatts. And I just went the wrong direction. So what are the applications? We're at right now working with an owner of a wind farm who'd like to add solar capacity. The right-of-way that he has for his generator lead is too small. You can use our line effectively to use that same right-of-way and move both the power from the solar farm and the wind farm down the same right-of-way without any expansion of that right-of-way. So we're looking to partner with folks such as utilities, data center developers, solar and wind farm developers, and offshore wind developers, all applications that we think have great opportunities for us. So remember Veer, more power, less tower. And I'll be out at the session later as well. Thank you.